Friends, today we are going to discuss about a buck converter or a book converter. Let's present the parts. We have this switch element. It can be a BJT or a MOSFET. We have the control circuit to turn on and off the switch. We have this diode, we have the inductor, we have the capacitor, and we have the load. This works in a principle of a DC to DC conversion. This type of power supply takes a high input voltage DC to a lower output voltage DC. The principle is that this regulates a voltage by switching it on and off. So that's why there is this control circuit. So this control circuit is the one generating the signal that switches on and off. So this signal is in the form of a PWM signal. You can see here, it's turning on and off. It's just a digital signal to control this switch here. This switch can be a MOSFET or a bipolar junction transistor. This signal is connected to the base in case of a bipolar junction transistor, and it's connected to a gate in case of a MOSFET. So this is going to drive this transistor here, this switch here. Now, how does this type of power supply works? When we supply here, it will find obviously it will find this transistor is off. So we turn on this circuit here. This circuit will be turned on. When it turns on, it also automatically it turns on the transistor. The current will flow. The current will go toward the inductor. Then the inductor works in a principle, it stores electrical energy in the form of magnetic field. Then when the supply is switched off, it will release that energy. So when it is on, this conduct and it's going toward the load. When the switch is off, so it is the inductor and the capacitor which is going to power the load. Now, after the switch has turned off, the energy will be released. Then it will no longer go back that way because it will damage so it will come here and it will find a least path here. So this diode, it will conduct now. Then the circle will continue. It will turn on again. At the turning on again, it charges. When it turns off, it discharges. So this diode allows the inductor and the capacitor to discharge their charges properly so that we don't damage the circuit. Okay? So that is how it works. So the inductor conducts when the switch is on. Okay? And the capacitor, the load will get power when the switch turns on. When the switch turns on, this diode will be in its reverse bias, meaning it will not conduct. This diode will only conduct when the switch has turned off. Then the inductor releases its charge. So when it releases its charge, now that is when this diode will conduct and it allows the inductor to discharge properly. So that is how a buck converter or a book converter works in short. So as the transistor switch is being continuously closed and opened, the average output voltage will be therefore related to the duty cycle. Okay, duty cycle. This duty cycle is defined as the conduction time of the transistor. Okay, this transistor here. Switch during its on and off switching cycle. So the transistor switches off and on. So when the transistor is switched on, we call it as time on, and when the transistor switches off, we call it as time off. Then to calculate the output voltage, the average output voltage will be calculated in this way. The output voltage will be equal to the time the switch is on over the time the switch is on plus the time the switch is off times the input voltage. Then the duty cycle we have said that it is the total time on and time off. So we'll have the duty cycle will be time on over time on plus time off. Okay, so time on plus time off gives us the total time. Okay, so we'll have time on over the total time now. In short, which is written T on over. In short, we'll get the duty cycle is equal to voltage output over the voltage input. So for us to calculate the output voltage, so this is how you'll get your output voltage. V out will be equal to the duty cycle times the voltage input. Let's say your duty cycle is 50%. So which means if you are 0.5, let's say you put 12 volt, obviously you are going to get something like 6 volt at the output. So that is brief how a buck converter work. So let's meet next time. Next time we are going to start with we are going to proceed with others. Thank you.